Hi again. I thought I would compare my MSO2024 Tektronix scope, which is current production, with the TDS 2024C. They're both looking at a glitchy signal that's coming off of a Quick Start 8 board made by Tektronix, which was designed for the TDS 7000 series digital phosphoroscopes to show off its capabilities. And both scopes are set for infinite persistence. And I'll turn the little one on first. So now it's acquiring. So any irregularities that it picks up, it'll show on the display. We'll do the same with the MSO. The MSO has a... Did I do that? Yeah, it's running up. There's a bunch of glitches already on the MSO. What we see on the regular TDS, no glitch activity so far. It may eventually, it's just kind of random chance how fast this one will pick it up. But this, I can't remember what Tek's saying, their MSO 2000s or DPO 2000s are capable of as far as waveform acquisitions. I think it's something like 5,000 waveforms per second, whereas on the 2024, the TDS, I think that you're probably pushing 500, if that. I'm not real sure though. I mean, you'd have to do some reading to really figure it out, but obviously the MSO here can see a little bit more, and we can look at the acquisition details, and it's telling you number of acquisitions, and it's up to, looks like 1,800,000 and so on. So there you have a look of how fast it's capturing waveforms. I think on the TDS 4000s it's 50,000 waveforms per second, a little bit less for the TDS 3000. TDS 5000 is probably, I think they were 100,000 waveforms per second, and like my TDS 784C, I believe that one's 200,000 waveforms per second, and I think the like 7000 series, I think they were touting those at around 400,000, but it may have been 300,000. I think they had to back off at one point as far as what they were claiming. But anyhow, you can see, we get rid of that. There's been a little more activity on the other ones. Oh, we just caught something over here. This guy just saw that something, little trigger hop or something there, so it did catch something after a while. The advantage of this over this guy is that if you're like looking at a number of lines, like, you know, maybe you got a chip with 100 pins on it you want to look at, and you're poking at those pins, on this one you don't need to stay on each pin for quite as long as this one, although from a hobbyist standpoint the cost difference might be such that it just isn't worth the extra amount of money. It has a larger display than the MSO has a larger display than the TDS, but the TDS has a pretty nice display. They're both small, but you want to stay small. I'm sure from Tek's perspective though, on the MSO they could have put a bigger display on this 2000 series, but they have a bigger display on a 3000 series, just like they have a bigger display than that on a 4000 series. And each instrument fills its own particular niche for the marketing people, just like I doubt very much if they had to make these with only 2.5K memory, whereas this one has 1 meg of memory. You can see that the MSO is the larger of the two, but not much. It has a relatively quiet fan, but you can hear the fan running. Much more sophisticated though when it comes to looking at signals and able to decode them by using little modules up here, so that you can kind of work it as a little bit of a logic analyzer, especially if you get the MSO type. Otherwise you're stuck to 4 channels or 2 channels depending on what you get with the DPO, which is fine for certain signal types like serial communications or I2 squared or something like that. Still waiting for something else to happen other than this one glitch, but really we were kind of lucky. I use this same glitch a lot of times with like TDS 500s, and you can go 3 or 4 minutes before you'll see a glitch on one of those, unless you switch it to InstaView, and then you'll see a glitch much faster than this. So you know, if you don't mind the larger scopes, such as a TDS 500B, or actually more waveform activity with those kind of scopes, because they're much more powerful, 200,000 waveforms per second, you know, kind of thing. So they're pretty powerful, but they are bigger, they make more noise, but probably they're no more expensive than this MSO2024, which is a current product. And they cannot do decoding like this thing can do. They can look at signals with better fidelity, but they cannot do the decoding. They just don't know what it is. Through the menus, persistence, clear persistence. There we are. And as soon as I cleared it, it saw another glitch. So this is a pretty active glitch, but it takes a lot of sampling to catch it. And so a typical TDS, any of these, whether it's a TDS 210, 220, 2000, 2000B, will be capturing waveforms at pretty much the same rate as this. I don't know if they publish a faster and faster rate based on the generation. I think it's all pretty much the same. So for glitch capture, you're going to like the newer MSO DPO, much more power. And even though this thing says that it's a 1 gigasample per second scope max on all 4 channels and 200 megahertz bandwidth, and this one says that it's 2 gigasamples, 200 megahertz samples, I don't know. I think that this one, when I'm looking at a fast 200 megahertz signal, I mean, it looks just as good on this one as it does on this one. You can't really see a difference, and so I'm not sure about that spec, if that's yet another marketing thing or what. But this one, I wouldn't be put off by that. Pretty neat little small scope. I bought it mostly for the MSO section down here, though, and being able to do some decoding with it for little projects that I play with. 10 megahertz signal, and I got a 50 ohm termination here because the signal generator expects a 50 ohm termination to give you accurate amplitudes. And so we can auto set. So there we have the TDS 2024C looking at a 10 megahertz signal, and it has a little frequency counter. I think I've determined that that's definitely a frequency counter. I think this guy has one too. So the TDS 2024, now the MSO 2024. The MSO has kind of a neat little switch up here to the right where I can press it and it'll show me the entire display and not have any dead space on it. Now bump the speed up to 200 megahertz. Okay, similar situation. We can do auto set if you want. What the heck? It should find it no problem. A little bumpy. Try auto set on this guy. Actually a little better looking. So 200 megahertz signal, frequency counter says, let me zoom in. So 200 megahertz signal, frequency counter is at 200.001 megahertz over here. And the same 200.001 megahertz on this side. Not quite as happy over here. Let's see, the level control doesn't have a sweet spot. So this is supposed to be sampling at 2 gigasamples right now, 1 or 4 channels. This one is supposed to be sampling at 1 gigasample. Right now 1 or 4 channels, doesn't matter. And pretty decent looking display on this thing. I mean, it looks good. It's better locked in than the other. So I'd say the acquisition, I mean, it just looks a little more sophisticated on this guy over here, which you'd expect since you're paying a little more. And of course this one has a very short record length, so I can stop the acquisition and using the position control. Pretty much one screen worth is all you got for record length. This guy on the other hand has the wave inspector and all of those search features, so I can use the run stop button to stop it. And then zoom in, zoom out. I can start going through the waveform record. That's all my waveform record, and you can see the cursor going across. If I look at the at channel 1, I have my DC AC coupling ground, and I believe the TDS224 has these too. Invert full bandwidth, or you can cut it down, or you can use a variable noise filter here. I'm not sure how to use that yet. Probe setup, fine scale offset, position, D-skew, but there's no 50 ohm termination. You just have your built-in 1 mega ohm termination, but no 50 ohm termination. Yet when I read the service manual and I look at the calibration procedure and the instructions for using the flute calibrator, those instructions imply that this thing has a 50 ohm termination in it. They don't say it directly, but it does imply that there is a 50 ohm termination in there, which I would kind of like to use. I think that's again one of those marketing things where the marketing folks have decided that if you want that, you'll get the next model up. But I could be wrong. I mean, or it could be a really wimpy termination. I think that they use a lot. That you can use active probes with this scope. You can't use active probes with this scope without providing a separate power supply and so on. But on this, you can use active probes with this, but normally an active probe requires a 50 ohm termination, but maybe they have a special part number that can work with a 1 mega ohm termination, since active probes are essentially buffers, so they can deal with that. But I kind of suspect that this might have maybe sometime when I get one of the probes that'll work in this, I'll look at its little I2C, or what is it, I2C chip, or whatever, I2 squared chips that they use in it to tell the device what kind of a probe it is. Maybe I'll copy that and then just attach it to one of these things and see if I get the satisfying click of a 50 ohm termination, and can measure it with a multimeter. No guarantee though that termination is can take much in the way of power. Usually you get a 5 volt limitation, but you may not want to be applying regular signals. Who knows? But I'd rather they would have stuck with the other type of interface with that, like with the TDS 500s, because there's so many of those probes available. Be careful when you buy active probes off of eBay. I have very bad luck with them.